Hello, people. Thank you for the hosts. Yes, it's me on a Tuesday with special content and stuff. It's a slink. Thank you for the host, everyone. What time do I call this? Well, it's, yeah, okay, I'm late. Dinner took a bit longer than I expected, so whatevs. Special content. Yeah, we're going to build a weird watch type thing. I've been sitting on this since Christmas. It's going to be a thing. It's going to be some kind of thing. I've got lots of other things to do as well. So I'm just going to grab my coffee and then we'll get started. I've got a couple of bits to do. So yeah, I'll be with you in just a moment and we'll get cracking. And also, thank you to Andy and Helkith for the hosts as well. Cinemo! I'm still in earshot, you know. My shop is too small to actually go out of range. Right, caffeine acquired. Ba-ba. Whoop. Right. So now comes the question. Adjust focus. Right, so what should we start with? I've got three main things to do tonight. How is the now tidy shop? It's not bad. It's getting there. There's still lots to do, but it's not like we don't have the time at the moment. Am I right, lads? Or am I right, lads? So, yeah. Let's just move this out the way for a sec. I left it there just so there was something under the camera. Whoop. Lads indeed. Yeah, so my bench is nice and clear now. So Hugh, Caradog will know there was an enormous pile of screws and junk just completely covering this section entirely. And the edge of my mat was actually like up here kind of thing. So it's all gone. It's all been dealt with. It's glorious. So yeah, that's now a thing. Have I dumped it all into a box in the back room? No, I actually sorted it out. I mean, like, I took out all the good stuff and then the remains. It got down to the point where I just looked at all the remains and was just like, this is all trash or I don't know what it is, and just put it all in the bin. It was a beautiful moment. Right, so we've got a couple of things to do. This is Kimbo's mouse, which is broken and needs, the left click is sometimes double tapping. It's very early stages, but it's the beginning of the end. However, I've got some spare mouse switches. These are mouse button switches, and I happen to have some spares. So we've got that, and then we've got the weird watch type thing. And the other thing I wanted to do as well is a little project I've been threatening to do for ages, which I might do as a warm-up, which is I'm going to make a motherboard jumper, so I can switch on motherboards without shorting them with things. So, yeah. Didn't you buy a kit and stuff, Helkith? Did you do it in the end? Just do it! So, where shall we start? I think we'll look at the mouse first. I want to see if we can get this out the way. At least the motherboard won't be cold. Yeah. I think we'll start on the mouse. And then once we've done that, then we'll do the kit. And then if I've got time, I'll do the stupid other little thing that I was going to do. So I'm going to quickly I'm going to clean this thing up first because it's not had some love in a while. And then we're going to take it apart and we're going to see if we can replace the switches on it. So let's start just by cleaning because it's gross. Ugh. Decontaminate. Soft plastic is really hard to clean because it just sticks to your cloth. Clean your mice now and then, people. It feels really good when you've got a nice clean mouse. This is just glass cleaner I'm using here. And I'm going to squirt a bit onto an old toothbrush. That's going to let me get into all of the gaps. There we go. Like I bought one. Don't use acetone. Don't use acetone, Caradog. No. I don't know what part of you thought that was going to end well. It went into liquidation. Okay, right. So this is a Cougar Passion X Innovation Orange Edition. So how does this come apart? We're probably going to have screw holes on the underside. So let's zoom in just a little bit. And I'm just going to give myself a full screen preview because then it makes it a lot easier for me to see if I am in focus, which I'm completely not. Zoom, enhance. 1, 2, 3, 4. Yeah, that looks pretty in focus to me. Good, right. So I'm going to dig under these skates. Actually, is there anything there? There is not. Ugh. There's a screw. Ooh. Ooh. Closer, closer. Too low. Yeah. And there's probably something under this lower skate as well. Try not to damage these. If I damage these skates, the mouse will feel a bit horrid to use. And then I'll have to buy some new stuff. You can buy this sort of thin, shiny plastic material they use to make the skates. You can buy it on my eBay and just cut it to size. But obviously I'd rather not have to do that. Just straighten that one out before I stick it down somewhere. There we go, I think that'll do. Okay, let's open this guy up and see what's inside, because this might be a complete waste of time. However, I have done this before. The reason why I have these spare switches... My mouse! The reason why I have these spare switches is because I've replaced all the switches in my own mouse before. So, I have done this. If you've got a beloved mouse, it's a very good mod you can do, because it'll make the mouse feel brand spanking new. It's very cool. It's not really worth it unless you've got a decent mouse. But yeah. How's this working? Oh, okay, so these... We'll just take off the skirts. And then there are more screws. Kimbo no doubt watching on in horror as I strip this mouse to pieces. And just be like, yeah, rip all of that off. You don't need any of that. There we go. So mice are amazingly unexciting inside. We'll do a quick tour of this one. So on the inside, we've got a big old weight there. That's literally just a metal weight just to make it feel bigger and heavier in the hand. That's all that is for. And then obviously we've got the clickers all come down. So that button there, that's got a big old push rod that goes all the way down there and so on. So then on the mouse itself, we've got an LED and an LED to make it light up. So those are the orange LEDs. And if we just take this board out, will that come out? Yep. So this sideboard here is kind of floating, and that's the side buttons. So the back and forward buttons are on there. There's the mouse wheel. So that kind of just, so that mouse wheel sits in, that mouse wheel sits in there, and that's a rotary encoder. Let's take you guys in even closer. Look closely. And focus. To focus. And let's have some light as well. Let's set all this up earlier on. Bam. And then we've got a selection of buttons. So that one is the that one's the DPI button. That one is the mouse wheel. So when that mouse wheel is sitting in there, when you press on it, literally just presses on that button there. And then we've got the left and the right click buttons. So these are the two that we're going to replace. And those are no... Oh, they're Omicron. That's the same brand as the ones that I'm going to put in, so that's handy. So, right. Ugh. Slink with his adjustable waist. Oh yeah, he's got one of those. Yeah, those are pretty rad if you're an MMO person. Right, I'm just gonna brush some of the schmutz out of this. I will give it a proper airline later on, but I might do that. Whoops! Oh, heck, I just dropped the mouse wheel. Oh no, it's a poor start. Oh, there it is. I found it. I was like, am I going to have to start digging through the junk under the counter, which has not been tidied up yet? My furry mouse. Oh no. Right, let's take off this cable. Cool. All right. So this is going to be pretty straightforward. We've just got to desolder. Oh, that's not very good. Those anchors aren't on. That doesn't matter. Those aren't load bearing anyway. Right, let's focus a bit closer. Okay, so we've got to desolder these two switches and put some new ones on. So let's wake up the soldering iron, get that going. This ain't Animal Crossing. It is not indeed. We've moved on from that. We're now on to electronics times. Your G600 broke after 2 years. That makes me sad. I'm a Logitech man. I've always had good performance out of Logitech mice, so that makes me a bit sad to hear that you had a duff one. It's going to happen though. Right, let's start desoldering this. I'm going to see if I can do this one-handed. So we've basically got to heat up. Actually, I tell you what I'm going to do. I'm going to use the reflow technique or the wetting technique. So the solder that's on here will be lead-free, which makes it a bastard to desolder. So I'm going to mix in some leaded solder. I'm just going to put some fresh leaded solder onto those joins, and that will lower the melt point and make them easier to move. There we go. Just like that. And now we're just going to, very gingerly, try and step this out. There we go, just like that. So the button was toward the right. I don't even need to wet these ones. There we go. Right, those are the old switches out. So now we'll clean up those solder pads and then we can put the new ones in. We're at a really awkward focal point at the moment. We're just sitting between two focus steps. Doo-doo. Hello, Paige. How's it going? Yes, Slink was kind enough to dump all of his Animal Crossing fans in, so all the Animal Crossing peeps are now have all come in to say, wait a minute, something's not right here. This Animal Crossing mod looks really realistic. Right, I'm just going to flow fresh solder onto those because I was a little bit slow and I've probably just duffed up those joints. And now I'm going to get my solder wick and clean them up. Whoop. Oh, I think my iron feels a bit too hot at the moment. However, if I'm quick, we should be okay. My iron is... I'm running my iron at 400 degrees, which is for working on laptops. However, this circuit board is much, much simpler than a laptop, and it doesn't need this much heat. So actually, I think... Can I adjust it? Yes, I can. There we go. Let's just drop it to 380. And if I'm lucky, I won't destroy this circuit board. Do. Right. Might need some flux to clear those holes. That's one. Can I get that hole to clear? So this is solder wick. It's just braided wire, which sucks up solder. So I heat the solder up and it flows into the braid and comes off of the circuit board. There we go. Right, let's get our new switches out. What inspired the work stream? I've done these before, just not in a long time. However, I usually only really do these streams when I've got good stuff to stream. So we've got a weird, stupid little watch kit that I've been sitting on since Christmas. And I've got a couple of other things to do as well, because one kit usually won't get me through an entire stream. However, we've got this mouse, we've got the kit, I've got a weird other little mod that I want to make, and like there's a couple of other knickknacks around the shop that I could do if we still have time. Like just random computers that I've been thinking of building. Like I've got enough parts lying around to just build up an old computer, which we might do later on. But we'll see. Building computers isn't terribly fun unless it's something exotic or it's for someone, you know. Right, let's put in this new switch. Ugh. And yes, soldering is also a, yeah, I am self-taught. I learned from YouTube. YouTube is a great place to learn. And now is these unprecedented times are the perfect time to be learning things. Right, just going to flow one there. So that's now holding the switch in place. So now I can do a really good job on the other one. Yeah, Slink had really good time on that. I want Slink back on. I want Slink back in the shop doing something else at some point. We've been threatening to do it, just the opportunity didn't arise. However, yeah, at some point, I've got bits to do Slink's other half's computer, and I'm really hoping that these unprecedented times will be over when we, well, soon enough, and then we can do another Slink and Neth stream. Right, come on, get on that. Oh, that's terrible. I need more solder on there. This is a really janky way of soldering, by the way, this apply solder to iron and then to subject. I should be putting this in some helping hands or something, but I'm being really lazy because we're going to be done with this in 10 minutes. Do, 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 do. There we go. Cool. Thanks a lot, Doobie. Gonna get my YouTube comments. Oh no. Oh no. Caradog, no. There's lots of people in my YouTube comments that get really angry about my soldering iron tip, and they're just like, you don't clean your tip properly, blah, 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 blah. And I'm like, okay, number one, I do notice the silver on the end. That means it's clean. And number two, this tip is about £10 to replace. So I don't care if I wreck it because I'll just buy another tip. So yeah. And Private Dancer, do what you fancy, my dude. But yeah, I would offer a co-stream or something like that, but I don't know if we're really set up for it at the moment. Right, so that's 2 new mouse button clickers on that. So let's put this thing back together, and then we're done with the mouse. So yeah, that was really quick. We're 20 minutes in. Just going to clean the grit out from the... Ah, damn it. I dropped everything again. Oh, God. Everything's gone flying. I need my soundboard just so people can spam the professional button. All right, I'm just going to do the thing. There we go. Right. Let's put this back on. Which way does that goes that way around? So this is the lens, and this is an LED optical mouse. So pretty much all the business goes on in this single chip on the bottom here. And I'm never careful. If it works at the end, it's fine. Anyway, all the business gets done in this one chip. And this chip is it's a Panasonic. It's a Panasonic 33508. And literally it does USB mouse encoding, button control, the rotary control. It does the whole lot in a single chip with a built-in optical encoder. And this optical encoder is literally like a 4-pixel digital camera. Well, it might have a couple more pixels than that, but I'm not talking megapixels. Like literally, it will have like 4 or maybe 16 pixels in it. And what it's doing is this LED here shines a light down through this lens onto the surface, and that because it's analyzing the picture in 16 pixels, and by watching the pixels move around, it can track motion. And that's literally all an optical mouse does. It's literally how it works. It's very simple. And so, yeah, that's it. And they've managed to get these things down to such a simple design now that they can be ultra cheap. Am I putting that together right? That doesn't feel right. Oh, that lens isn't remotely aligned. It needs to move right back to there, I think. Who's blowing up my phone? Someone who needs tech support, which I'm afraid they're not going to get right at this moment unless they happen to show up in the stream. Right, that little sideboard goes there for the side buttons. Right, and I think we can now put the body of the mouse back on, which we've already cleaned up. Oh, mouse wheel. Where did I put the mouse wheel? There it is. That's got to go back in. Trying to get that to line up with the hole. Is that it? I think it is. Yep, there we go. That's doing the thing. That goes into there. Doo-doo-doo. Cool. Right, all our buttons line up. Everything clicks and rolls. Sweet. Put the screws back in. Doo-doo. Yes, temperature adjustable soldering irons are king. They're not required, but they are helpful. You can do soldering with the crappiest iron in the world if you've got the right technique. I actually did that's the wrong screw. We've got some flat screws and some round screws. I actually did a video recently on my YouTube channel where I actually demonstrated. I did surface mount repair on a graphics card with a really crap, like the worst soldering iron money can buy kind of thing. Well, not the worst, but a really awful soldering iron, just to demonstrate that good equipment helps, but it's not critical. So yeah, it's all about technique. What about the USB cable? Oh no, damn it. It should be wireless, Kimbo. I would have gone the whole way before I'd noticed that. Professional, yeah. Oh, God. We need... Oh, got it. Oh, hacking the whole thing. Kimbo, why did you stop me? I was happy, Kim. I was happy. Right, okay, that goes around that. Right, what are they doing with the cable routing there? Yeah, it must have been just like that. Didn't really see how the cable was aligned when I opened it up. And it's not really apparently obvious. Right, are we still good? We're still good. Plug that in. Just check that the wheel still wheels. Yeah, that's good. Okay, right. That goes in there. And that goes on there. Oh, I've got the thing too far back. That needs to move forward to about there. There we go. That all looks good. Yep, okay, screws back in. 200 to 450. Yeah, that sounds about right, Helkith. So yeah, a typical adjustable soldering iron will usually do 200 to 450. And on hobbyist electronics and small things like this, I would be running at 380. Then if I was working on something serious like a laptop motherboard where you've got a big 10-layer board, that is just solid copper that sucks up all the heat, that's when you need like 400, maybe even 420 indicated. So yeah, right, now the little side bits go on. Doo-doo. I forgot to plug the cable in, Slink. I'd started putting the mouse back together and Kimbo was just like, baby, the cable! Well, that's how you make a mouse wireless. All you have to do is just unplug the cable from within and it will reconnect with magic. It'll use it'll use 5G and make you ill, because that's what 5G does apparently. It doesn't do that. Oh, we don't have commands at the moment. I've only got a basic setup on Firebot. My smart meter is going to kill me. Oh no. Okay. Oh, I missed anything. Just the skates on the bottom. All right. I'm hoping this just sticks back down. Otherwise, we might need to do a little work with that. Oh, that's all good. It's sticking down just fine. It doesn't look fantastic, but give it a couple of days of being used where you're pressing this down against a mouse pad and moving it around all the time, and that'll flatten back out again. If you're doing a repair like this and this sticky back is not working, you could use something like a hairdryer to reheat the sticky adhesive, and then it'll go back on again. Give it a bit of heat. Okay. Just gonna scrub that a bit. Yeah, that's all good. Just making sure that none of these get ripped off. Good. I think it's good. Let's plug it in and make sure it works. Just for posterity. Ugh. She'll be all right. That's not how it goes, Caradog. She'll be right. Alright, and plug in. If the stream cuts out, it's because the mouse crashed the computer. It works. And just for evidence that it works, let me just close that and just switch to that one. And as you can see, yeah. Oh, up there. There we go. The mouse works. Did it. Right. And bench cam. Device is ready. Okay. Does it click though? Oh yeah, good point. Yes, it does. And the clicks feel really good, like it's got brand new switches in it. There we go. Job number 1 done. Mouse repaired. You're welcome, Kimbo. Add Bluetooth. No. So now allow... Oh, God. Cherry MX Blues in your mouse. Mouse switches are already horrendously clicky as it is. But you can buy really fancy switches. As I say, these are Omron. But like, there's a fancy brand that I forget the name of. You're right, Kimbo. Don't let me forget it. Actually, where's my car keys? Legitimately, I'm going... This is a trick that my dad always does. If there's something that you must not leave without, wrap your car keys around it. So then you physically can't miss it. There we go. I've wrapped my car keys around the mouse so it will not get forgotten. Okay. Right, should we start doing this stupid watch? So, firstly, so here's what we're making. It's a watch. So, yeah, I would call it a smartwatch, but it's not very smart. This is basically just, it's got date and time on it, and it's got an OLED display. Does your watch have an OLED display? Yeah, that's right, I didn't think so. Don't say anything, people with smartwatches. I'm looking at you, Caradog. So yes, it's got a watch band. It's got an acrylic case. It's got a charge lamp. So yeah, let's get into it. So I'll take all these bits out and we'll have a look. It's got a set, yeah. So I'm going to do some modifications from the design of this, or rather some optional things. I took all these bits out earlier on today just to check that I had everything that I needed. Had to go down to the hardware store and buy some button cells. So, oh, I'm doing this a bit high, really. Hold on, let me just adjust. There we go. So that's our watch face, and just for comparison, that's how big it's going to be on my wrist, kind of thing. So it'll be pretty chunky, but the screen will be really small. So that'll be fun. So this is the main circuit board. This screen will be double taped down there, but we'll put everything on it first. So we've got to populate all these components. The screen is the only part that comes pre-soldered because this uses what's called a hotbar attachment, where this has been soldered, but I'll give you a close-up of that. So this is a method called hotbar, which is how a lot of ribbons like this are soldered on. And as you can see, it's been soldered onto the board, but literally they've just gotten that ribbon, put solder on it, and they've just used like a really wide bar at soldering temperature that just magically solders all of that at the same time. These things are notoriously bad for failure. However, we're not exactly expecting to get 10 years service out of this thing. So, you know, there's that. 1, 2, 3, 4. So then the other circuit board here, this is the power board that needs to have 4 button cells on it. And so it's literally going to have 4 button cells. But I was reading the instructions here, and if we actually look into the design of this thing, it actually comes with all the schematics and everything. If we look at the design, we've got the OLED display, we've got a microprocessor that does all the magic, and then this chip is a real-time clock chip that does all the timekeeping and all of that. It's actually got 5 in it, but I'll get to that in a moment. This chip requires a separate, it's going to have 5 button cells in it because there needs to be one for this as well. So yeah, I know, right? And then this is where it gets interesting. This chip here, this is a TP4056. This is a lipo charge control chip. So interestingly, when they designed this thing, you can see all the photos of it populated here. They designed this thing with a USB plug on it, and it comes with all of this, and they designed it to be USB rechargeable. However, in these kits, they don't want to supply batteries and lipo cells and stuff like that, because then they can't keep it on a shelf, and it's more expensive, because these things obviously cost pennies to manufacture, and blah, blah, blah. So they ship it with this arrangement for 4 button cells plus 1 on the main board for the timekeeping. However, I've got this teeny tiny little 200 milliamp hour lipo cell. So we're going to substitute this battery board for this tiny little lipo cell, and according to the schematics, it's got all the electronics needed to do full lipo charge control. Stick an 18650 in it. Just so people know what an 18650 is, that's an 18650. So that's not going to fit, Hugh. That's not going to fit. 18650s are awesome, though. I have a box of them that I've scavenged out of laptop batteries. Very good for torches. So, yeah. Right. Anyway, so yes, we're going to try and power this from that lipo cell. But firstly, we'll build up the main board. So I'm going to grab a couple of bits. I need to... Oh, there it is. I've already got it on hand. So I've got my soldering iron here. I've also got a component tester. We built this on an early electronics stream, so I'm going to use this to help me identify some of these parts. And we've got to put all this on. So let's go in for this. Let's start coming in for the close-ups. I need my preview screen back up so I can see my focus. Single cell be high enough to replace 5 batteries. Yeah. The 1, 2, 3, 4, 5, maybe 6. Alex in focus. Yeah, I mean the instructions specifically state that it can be powered from a lipo cell, and I think they're using the batteries for current handling, because tiny little lithium button cells. So these kind of things, these tiny little lithium button cells, they can't pass any useful current at all. They've got the voltage, you know. I mean, like you stack up 4 of these, and you've got, well, 3 times 4, you got 12 volts there. And they were doing a 2x2 formation, so they were going 3, 6, and then I think they're paralleling them for 6 volts. So 2 pairs in parallel. However, even then, it just doesn't have any current handling at all. You guys who have seen my Mario coin block, the little thing that goes da-ding when you press it, I did a LiPo conversion on that, and it made it 1,000,000 times better. LiPo has got less voltage, but it's got so much more current in it that it can just power big, powerful things. Big and powerful. Anyway, let's identify some of these parts. I'm going to adjust my camera so it's less in my way. Strong and stable. Oh no. Let's have a look at some of these parts we've got. So all these little coin cell things, we'll put those to one side because we're going to use one of them for the RTC battery. So we only need one of those. The rest of them I'll put to one side as not used. And we've got a bunch of passives. We've got quite a lot of resistors here. However, they're all identical. What are these? These are 103 they have written on them. You can might just be able to make that out. That's 103, so that's 10 and 3 zeros. So those are 10,000 ohms or 10k ohms. So 10k resistors. And we've got some tiny little surface mount capacitors. So these are mainly for stability. They stop the circuit from crashing. We've got a couple of side buttons for our setting. We've got some more there. What are those? Those are 202. So that's 20 and 2 zeros. So that's 2,000 ohms, 2K. We've got some little 3-pin jobbies. These are probably dual diodes or something like that, maybe transistors. I've got an LED, that'll be the charge LED. Another transistory type thing. This is a voltage regulator to generate a 3.3 volt reference. However, apparently this is not needed if we're running on LiPo, because that goes on the battery board. We've got a couple of diodes there. Those are in. So these are round packages. These are like normal through-hole components, like this sort of style here, where you have legs coming off of them. It's just they don't have the legs on them. That's called a MELF package, MELF. I can't remember what that stands for. It's also known as a roll-away package, because if you put it on the desk, it'll roll away straight away. And then we've got this chip here. I think this is our micro. It's an IAP 15W4K and some other numbers. And then we've got, I think that's our clock chip. And then somewhere around, oh, there it is. Oh, that's our clock chip. And then that is our LiPo regulator. So we're going to start out by putting all of the big stuff on, a la the chips. And I'm going to try and soldering iron hero this. So let's get aligned. So that's got to go on there. Let's get the soldering iron on and let's get started. Yep, MELF. It's a known thing. They're very cheap, but you can use them surface mount. Right, the soldering iron is coming up to temperature. Right. Does that picture look good to you guys? Can you see what I'm doing? What we need to do is get solder onto just one of those pads so we can get this guy soldered in place, and then we've got to go around the sides. I'm going to go straight in with a bit of flux on. Actually, let's get one soldered down and then we'll flux it up. Metal electrode leadless face. Ah, there you go then. That's what it stands for. Right, so I'm just going to touch up one pad. Oh my god, this solder is way too thick for what I'm doing. There we go. That's literally just one pad I just touched the solder against. So the chip has got a dot in the bottom left, and I'm aligning that with the dot on the circuit board printing there. That's how I know which way round it goes. So we're going to try and line this up. This is going to be the hardest component on the board, which is why I'm doing it first. And we'll just melt that solder. There we go. And are we straight? Not quite. I need to just rotate that just ever so slightly. A bit more. Oh, damn it. Heck. This time in about 2 minutes, I'm going to wish I just used the hot air for this. Whew. Crumpets are good. Alright, now we've got to solder the rest of it. So to make this bit easier, because what's going to happen is the solder is just going to bridge and just blob across all of these pins. So I'm going to use flux, which will make the solder more liquid-like, and it will stop it from blobbing up. So I'm just going to put a little bit of that all around the chip. Flux is not necessary. However, if you're doing heavy SMD stuff like this, I wouldn't call this an advanced project, but I wouldn't make this the first project you ever do. So yeah, for most soldering work, you don't need to add your own flux. However, for this, I'm going to. Okay, not sure if I actually captured any solder onto those pads then. Let's do another side, and we're just going to go around a couple of times, and then I'll stop and inspect. You're all terrible, and you know why. Heck, I'm not getting any solder onto the iron there. There we go. Next side. As you can see, I'm just turning the device around just so it lines up with where my iron is. Make the device work for you. Don't work cack-handedly. I don't think I've got enough solder here. However, if I go in any harder, I think I'm just going to put a massive solder blob on there, and then I'll have to clean up. It's easier to add solder than it is to take it away. And that side, we'll just do this much and then we'll inspect it. If we have any problems with this, this is the most likely place for it to show up. There we go. Right. Now we'll inspect and just see if that's all come out nicely. Okay, close up. Yeah, they're touching, but you can see, like, the top left, you can see there's no solder on those pins. That's no bueno. So we got some of them, but yeah, we did not have enough solder there at all. So it's a bit hit and miss. Some of them we got, but a lot of them, yeah, there's not enough solder on that. So yeah, we've definitely got to do something there. We'll go around the whole thing again. 1, 2, 3, 4, 5, 6, 7, 6. I'm counting focus steps. Okay, here we go. I'm going a bit heavy-handed now. There we go, that must have done the job. Are we in shot? We are. We're good. Oh, that's a big old bridge I just made. Oh, that's another one. It's exactly what I didn't want to happen. All right, so we just put in some massive solder bridges there. So you can see where I've just joined up pins there. So now I'm just going to wipe the soldering iron down. And I'm just going to run the soldering iron back across those. And the soldering iron should pull some of that solder out. If it doesn't, there we go. We've got one of the bridges. Let's see if we can get the other one. Yeah, there's way too much solder there. I'm just going to dab my my solder wick against that just to suck out some of the excess. More. Whoops. Oh, come on. There we go. And we'll just run along the bases there. I think we're good. Let's be a little bit less aggressive with the solder this time. See, because this solder is too big, it doesn't want to move to such a small target. Instead, it wants to jump to easier things. Oh, that's a huge solder blob. I'm literally just going to trim the end of my solder at this point, just to get rid of that blob. Oh, that's a lot. I think I can save that. I did not save that. I made a massive solder bridge. However, now it's all sorted. You know what? I'm just going to do the same thing on this side. I'm just going to bridge everything together and then make good. If it's all bridged together, we know there's definitely solder there. There we go. Did it. Whew. Okay, let's pull out those bridges. Once we're past this bit, everything else will be easy. But this is, you always start with the hardest component. Oh heck, that might have been too much wick. I think we're good. Right, I've got one more bridge to pull out, and then I think we're there. Come on. Get out. There we go. Right. Time for inspection. Huh. That's better. Those ones are still a bit anemic, but they are actually soldered down. You can see where there's areas where there's lots of solder and area where there's not much. I was struggling a bit on that guy. That side is definitely a little bit mean. However, those guys are actually soldered down. That's passable. Yeah, that'll do. Right, now I'm going to clean. Need my alcohol. Ooh. Precious isopropyl. This will just get rid of the flux residue that I've left everywhere and make everything nice and clean again. Focus. 1, 2, 3, 4, 5, 6. There we go. We have a microprocessor. Cool. Right, let's put on our other chips. Actually, I might start... See, we've got a chip that's going in there, and that's going to make all of these little bits in the middle hard to get to. So I might do these resistors around the side first. Let's turn that around so it's the right way up. Right, so I think I'm going to put on the 2K resistors because we've got 2 of these. I'm just going to get those out of the way. So where do the 2K resistors go? Oof. Studying blueprints. Let's get these under the thing so you can look at them with me. Right, where's the 2K resistors? Right, 10K, 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 2K. There's one. They do sometimes give you spares, so there might be a single 2K resistor. I think there is, because I can't see any more 2K resistors anywhere. I think it's just that guy there. And the other one we've got is a spare, because everything else has got 10K written next to it. So who was that? That was R0. R0. So this is for the charge chip, which is there. So R0 is in the top left. Let's stick that on. Warming soldering iron back up. So let's open up this little package here. And I'm going to need my tweezers. There we go. Right, so banana for scale. There's my pinky finger. So this is what we're dealing with at the moment. So this is not as small as it gets, but this is... we're getting down to you don't really want to be hand soldering stuff much smaller than this. It gets a bit of a ball ache. Right, I'm just going to put a little dab of solder on there. And I'm going to move that guy around to there. And I'm just going to heat that solder and move the resistor into it. There we go. And now we'll just solder the other side. You guys need to be a bit closer, really, don't you? Ooh, let's go in. Let's go in super close. We'll go for the slight angle so you guys can still see, but also I can. Oops, too far. We're losing depth of field at this range. There we go. That'll do. Okay. Right, that's the 2K resistor done. I'm going to put the other one over there because I don't think we need it. So now I want to build up these guys. So R3, R1, R17, and what's that? C9, I think. So these guys will all be the same because we've only got one strip of 10K resistors and all of these capacitors are the same value. What are those? They are... The capacitors are all 105, so that will be 10 and 5 zeros. So someone can work out, what's that, 10 and 5 zeros, that's 100,000. So that's going to be 100 nanofarads, I would expect. Which is, and farads is the unit of capacitance. So I want 1, 2, 3 of these resistors. One, two, three. I discovered earlier on this afternoon when I was setting up for this stream that apparently my internet at work is a lot better than my internet at home. I did a speed test and it's just like, I've got 20 meg upstream here in the shop, whereas at home I've got like 8. I'm sad about it. So yeah, that's why we're blistering out at 1080p, 6 megabits per second at the moment, to get what hopefully is pretty decent quality. I hope it looks good anyway. I've no idea how good this is coming out. Right, let's get you in. And the other side. That's not very straight. No, it's too late to straighten that. Fine. It's going on wonky now. Go on, give me a bit more. There we go. No, that's too much. Heck. There we go. Resistor and R1. Hello. And resistor. You know, this kit is going to take a lot longer than I thought it would. It's a good kit for me. A lot of the kits I look at and I'm just like, that looks boring, there's not enough to do on it. However, this one I think is actually going to be incredibly fiddly. Typical business connection. No, I have a residential connection here. Pro tip, don't get a business account unless you actually have to, because quite often you will get worse service on a business account. No idea why. It's just the way it be. I've got friends who were running businesses, and they were just like, oh yeah, get business accounts for everything. I had nothing but trouble. Whereas me, with residential consumer accounts for all of my suppliers, you know, Amazon and all of my utilities, it never, ever had a problem with it. Of course, if I was VAT registered or something like that, it might be different. Has that soldered? It has. God, this is really finicky work we're having to do here. Right, let's stick on one of these capacitors. Oh, I've got to try and open this packet without spilling them everywhere. Whoop. Do. Try not to nudge the camera. Ooh. Come on. Lay flat. There we go. This one's not going to be perfectly flat just because there's solder on both pads already. I could have cleaned the other pad up, but who's grading, you know? Can we get both sides? I'm going to put a bit more solder onto that. We are working at a pretty small scale here. This is pretty much as small as hobby kits go, I would say. Yeah, you'd be surprised. It depends, really. I think my property is a very weird lean-to. It's not a big place. It's practically a shed. So I think that might be why I get away with it. Right, so we've done these little guys in the middle. No, those are transistors. So we're going to stick on this chip here now. So I'm going to solder up that pad there. So that's our charge control chip, which is going to be the smaller of our 8-pin packages. I'll just take this out of the packet. Ooh. Right, so this guy. So this guy is a lipo charger chip, and a lithium cell. It's very simple to charge up. You have to. A lithium cell runs between 3.2 and 4.2 volts. They can go down to 3 volts, but typically you run them between 3.2 and 4.2. And in order to charge them, the first thing you have to do is bring the voltage up. You charge the voltage up to 4.2 at a fixed current of, say, an amp. It won't be that much for this tiny little thing. I'll charge this at 0.2 of an amp, maybe half an amp tops. And then once the voltage reaches 4.2, you then hold that voltage and the current will slowly tail off instead. So it's a two-stage charge process. So you need a chip to control that. So this guy does all of that for us. It handles all of that voltage management. And it's probably got a voltage step-up converter in it as well, because it's got to accept a 5-volt input, and it's got to step that voltage down to 4.2 to charge the chip, and then it's got to step the voltage going back out up for the device that we're actually powering, because this thing is expecting a 5-volt rail. So let's do this, and I'm doing this left-handed, which I shouldn't be. Oh, blimey. I should swap. Why am I doing this left-handed? I literally said at the start of this stream, turn the device around and make it work for you. Right. There we go. These pads are very widely spaced, but they've given me lots of space to make it easier to solder. But I've got to get the positioning right. Okay, I'm just going to look at the picture to make sure that I've lined that up correctly. So the dot... I have not lined that up correctly. Am I correct there? So... No, I'm looking at the wrong... No, I'm soldering the wrong chip in entirely. That's not our charge control chip. That's supposed to be the real-time clock. Wrong chip. Good thing I checked. Someone would have had a bad day if we'd left that on that. That'll be why the pads were so widely spaced. Check your work, people. Don't be a hero. Made that mistake too many times. So this chip that we're now putting on is the real-time clock. And this is literally the chip that does all of the timekeeping. So this micro runs the show, but this guy is the one that does all of the counting. So this keeps the clock, and it has its own battery that'll go over here, which will keep the time in it when the watch isn't running. So, right, and this guy is significantly bigger, which is why it seems to fit onto these pads better. There we go, let's get you on there. Better? Right, and did I put it the right way round? I did. It is the correct way round. We did it, everyone. All right, let's solder those other legs. Bit too much solder on that one. I'm going to wipe that down. And it's going to be a little bitch and not do that, but that's okay. Whoop, whoop, whoop. There we go. So these pins are a lot more spaced out, so it's much easier to solder these pin by pin. Just going to reflow those to make sure they're happy. There we go. We just managed to scrape off a bit of the excess as well. All right, that's our timer chip in place. Man, that resistor is really off kilter. I really want to move that guy, but it's going to be a pain in the ass. I'll need a hot air gun to effectively move that. Am I going to move that? I'm going to move that. It's annoying me. I'm just going to put this on a heatproof mat because we're going to hot air it. Hot air station on. 400 degrees. Low airflow. So this is a hot air gun that I'm bringing in, and it blows hot air at 400 degrees. So it's going to melt all the solder in that area. There we go. That's cheat mode. I'm deliberately not using this because it's cheating. The idea of these kits is that they're good soldering practice. If you use a hot air gun just to zap everything to the board, kind of defeats the purpose, if you ask me. Although there are some projects where it's a case of, no, you should use a hot air station for this. Have the police bothered me during the lockdown? No. I'm very surprised. I mean, now and then I see either a PCSO walking by or a van goes by, and I'm expecting them just to walk up and just be like, are you supposed to be here? To which I would say, yes, I'm fixing people's computers who are trying to work from home. But no one stopped by at all. So yeah, I haven't been bothered. I've had almost no customers at all. I've had 2 computers come in. Well, no, I've had 3 computers come in this week as opposed to 20. So, you know, I'm not exactly busy. Oops, I keep stabbing the camera with the soldering iron. I've got to put this thing down when I'm not using it. You got a letter? Yeah. I have no such thing. If the police ask me to close, I will close. However, because I'm helping people work from home, I believe I'm doing necessary work. That's my take on it. Right, I think we'll put in these transistors. So these guys are designated Q1 and Q2, which makes them transistors. Now the problem is, we've got 3 transistors here. Are they all different? I'm going to need to do some close-ups so I can see what I've got. Two TY. Ooh. Come on. J3Y. And 662K. Yes, they're all different. Right, which one goes where? Two thank yous. Yeah. It's marked. Okay, so if we turn this around, that's in the correct orientation already. Right, so we go 2 thank yous, J3Y 662. Someone remember that for me. 2TY J3Y 662. Right, so where's the 2TY gone? 2TY is the first one I picked up. There we go, 2TY. Cold calls, yeah, people keep falling for it. Every week, well, you know, except now, I have people coming into my shop saying, oh, Windows called me up and said I had a problem with my computer. And I'm like, no, they didn't. You have been scammed, my friend. Anyone calls you up saying that there's a problem with your computer, you are being had, son. Okay, let's park him there for a sec while I tin up the pad. Oh, I'll put that upside down. That's fine, we'll get that in a sec. So let's go ka-chow. Little blob of solder. So transistors are digital switches. When you apply a small voltage to one pin, when you apply a small current to one pin, a larger current flows across the other pins. So they allow the microcontroller to switch on a bigger circuit. Now, the building blocks for all modern digital logic, and I'm making a hash up of this one. There we go. Zap. And zap. These transistors are almost certainly being used to drive the LCD, the display. This is an OLED display. And this thing will be sucking too much power for the microcontroller to push directly. Might also be handling other things as well, come to think of it. Actually, can we see where they are in this schematic? Okay, so these are handling the switches. Well, I'm not sure why. Yeah, so these are being, on the schematic, they're handled over here. And this part of the circuit diagram, it's got the two switches in it, which are the two buttons for setting the time and stuff. So these things are being used to they're being used to bring the switch voltage high. Oh, I think I know what they're doing. So most likely the control logic, so the microcontroller, doesn't have enough power to generate a really nice high logic signal. What's up, Iron Bagel? How you doing, my dude? So what they're doing is that they're using these transistors to make a big voltage difference to switch things on. So yeah, they're being used in a pair. It's to do with switching the whole device on, basically. They're power switches. So yeah, I'm not going to do a full reverse engineering on this. I'd have to sit down and scratch my head for a long time. I can probably make sense of it given time, but I'm not an expert. Okay, right, that's our first one. What was next? It was the one that wasn't 662. I haven't blessed you by not wearing it. Oh. J3Y, that's our dude. Right, let's get this guy out of the packaging. Man, I'd forgotten how long it takes to do these on camera. Well, I'd forgotten how long it takes to build these kits. I always look at these kits and think, oh yeah, we'll have that done in an hour. Huh. The mouse didn't take very long. Although we're only up to an hour and a quarter. Feels longer than that because it's gotten dark outside while I've been streaming. So it feels like a long time has passed. Right, let's get this guy lined up. Oop. Turn it round. Turn around, bright eyes. And on you go. Up. On you go. And hold down. Oh, it's not straight. Unacceptable. There we go. That's the biggest struggle with these, is getting everything straight. Heading off for a short walk. Yeah, no problem, my dude. 10 minutes into the recording. Yeah, we achieved a hell of a lot in the first 10 minutes. We fixed a mouse. 10 minutes into the recording and we've achieved everything. Just got to dig into those little bits there. Get in there. Go on. Hacking. Balls. Got a really narrow gap I've got to get the soldering iron into. Let's stick a blob on the end of the iron. There we go. That'll do it. If in doubt, blob it. Fix it later. Okay. Right, that's that section. Let's do the other transistor while we're doing transistors, and then that's our 3 trannies done. See, Slink, what you've got to do is open your window, and then when Andy passes a certain spot, Andy just goes, "Ahoy!" And you just yell out the window, "Ahoy!" And you both share a special moment in the night. There we go. Right, this is the 662 whatever. The reason why, although all these transistors are doing basically the same thing, and the reason why they're different is that they will have different characteristics. They'll be designed for switching different amounts of current. Some of them may be N channel, some of them might be P channel, and that's to do with their natural state. An N channel MOSFET, an N channel transistor is naturally off, so it doesn't do anything until it's switched on, whereas a P-channel transistor is in a natural on state, and you apply a signal to it to switch it off, so it's the other way around. So that's why we've got different types here. They would have used the same one if they could, because on an electronic circuit, wherever possible, you want to reuse the same components, which is why they've managed to make it so all these capacitors are identical, so they can give me this long strip, whereas they had to put 3 different transistors on, which probably made the designer very sad. It was like, oh really, we can't use the same transistor anywhere else? Heck, I've got a solder blob again. Get rid of that. And on the top. Oh, come on. Got some horrible blobbage going on there. Let's just tidy that up. That'll do. That's possible. Whew. See if we can get you guys in close again. Let's go in for the super close up for this next bit, I think. I'm going to adjust the camera angle slightly. I'll fix that weird perspective as well. I have planned for this. Whoop. Flip you guys onto the other side, and I'll bring my face back. Whoop. And focus. There we go. So you're working across the desk from me now. However, it stops the perspective from being weird. And you guys get a really good close-up of what I'm doing now. That looks awesome. Okay. Right. What should we do next? I think we should put on the other chip, because we should do all of our chips first. So I'm going to stick our lipo chip on. And as a special treat, I'll put it the right way around. So the dot points away from the circuit board, which is what it says on the silk screen here. You can see that little half moon cut out there. That indicates that pin 1 goes there. So, and in addition to that, you'll notice if you look very carefully, you can see that that pad there is square, whereas the others are ovals. The square indicates pin 1. And that's just universal layout design stuff. So you'll see that on anything. I'm going to have to turn this around so I'm not soldering cack-handed. I think that'll do. I think you guys can see that. So the only problem with using this camera angle is now my view is mirrored. Whoop. Come on. Oh no. Oh. Holy tombstone, Batman. Oh God, hold on a sec. Let me just do this with my finger. That went horribly wrong. Let's try that again. Come on, guy. Move. Move. Heck. Whew. You know, I could put this in some helping hands. Oh, really? What am I getting hung up on here? Hang on a sec. Oh, I know what's going on. I've got a little bit of solder from where I previously soldered it. There we go. There was a tiny little solder blob on one of the other legs that was catching. That's why it wasn't skidding around on the board the way I wanted it to. Get on there. There we go. Right, now we can solder these other connections in. Oops, that's a lot of solder I just put on that leg. See if we can borrow some. There we go. That little scraping motion I was doing there, that's a method known as drag soldering, where you get one solder blob and you drag it across the pins. Sometimes it works, sometimes it doesn't. Depends what you're doing. There we go. Just make good on those. That's all good. And that's that done. Whew. All right. And that is that chip in place. Okay. Right. Next, I think we're going to put on a whole bunch of capacitors. Because we've got a whole bunch of capacitors that need to go around this screen that are all designed. These are all signaling stuff. If we have a look at the schematic again, you can see that around the bottom of the OLED display, there's lots of capacitors. All these C markers here, those are all caps. And those are there for signaling. Some of the signals will be AC coupled, so it'll be a wave signal going in. And some of them, like these ones here, go straight down to ground. That's just for stability. It helps stop shimmering and things like that. Make sure that there's no voltage spikes doing it in. Right, and I'm going to try and work from this angle because it means that I can flip the display around again. Actually makes my life a lot easier if this is the right way around, because I can actually see more by looking at the screen than looking at the board, because the screen is blowing up to a 24-inch monitor. So yeah, it's actually very helpful being able to, even if I wasn't streaming, it's really handy having a camera on your work just because you've got an instant inspection camera all the time. So let's do these caps. I'm gonna go around and just touch up one of these pads for each one. That one. There we go. Right, what was that? 1, 2, 3, 4, 5. 5 capacitors, please. Where are my capacitors? They are there. So I'm going to go 1, 2, 3, 4, 5. Okay. Let's get these guys on. Whoops. I'm working right under the camera here, which gives you guys an awesome view and me a terrible view. The camera is about 2 or 3 inches away. So yeah, that's what I'm dealing with. Get in that. Next one. Actually, I'm going to touch that up now, because when I put the next capacitor on, it's going to block that that pad. So I was going to do 4. I was going to do 5 in a row. However, I'm just going to touch up these ones independently. There we go. Capacitor. Yep, that looks good. Touch that up. There we go. These guys are a bit easier to do than the resistors because they're taller, which means I've got more to grab hold of with the tweezers. And I'm going to work cack-handedly again. Do as I say, not as I do. Oh, no! Oh, he fell off. God, this is horrendously fiddly, but this is also a really fun challenge for me. Hecking heck. What am I doing here? Let me turn that around. Right. Get on there, you dick. Oh, I've got the shake. There we go. If you think you got shaky hands, that doesn't mean you can't solder. I get a shaky hand, and the trick to that is learning how to manage it. If you've got a shaky hand going on, you've just got to find a way of anchoring your hand down to a solid table. Like if I try and hold this tweezer in place, you can see that's my movement at the moment. You can see the shakiness going on there. However, if I then adjust my grip so my wrists are anchored down, I can then do that and just press everything down. The iron has still got a bit of a shake, but that's okay. It can. So yeah, a lot of people reckon they don't have the hands to do this kind of work. You can do it. It's all in the technique. I'd imagine artists have the same issue sometimes where you get the shaky hand going on. Heck. These tiny capacitors are, well, the resistors were worse, but the size we're working at here is really obnoxious. Whew. Get the other side. That guy's not, no. I was going to say that's not straight, and then I'm like, no. We're going to be here all night if I try and get everything perfectly straight. And while we're doing all right for time, I don't want to be here all night. There we go. There we go. Bam! What was that? Oh. It was a gritter, putting salt down on the roads. Love your content. Oh, thanks a lot, dude. Thank you for the embers. Hello to you in Mexico. I hope you're doing all right out there. And as I say, thank you very much. Much appreciated. Right. Okay, that's those capacitors. Let's do some more. In fact, I think we can finish this side of the board, really. So what have we got? Resistor, resistor, capacitor, capacitor. We need another 2 capacitors and 2 resistors. And that is our charge LED there. So let's get another 2 capacitors and another 2 resistors out. And then we'll do the LED. The LED is going to be a little bit tricky because we've got to check which way round it goes. And I can never remember. 2 capacitors. 2 resistors. And again, we're just going to tin up the pads. Off. Are we on shot? We are. Off. Oops. Pro tip, if you've got to get around a really awkward angle, just put a curl in your solder. That's the great thing. You can actually aim your solder where you need it to go. Oh, I'm missing a resistor. Oh, I found it. God, that was lucky. One of those goes walkabout, you'll never find it again. Right. Let's start with this capacitor over here. I'll just move back in shot. Who's that? It's Bebsy with the host. Hello, Bebsy. How you doing? Welcome to Tiny SMD Electronics Soldering. Something a bit different from the old Animal Crossing. There we go. We're soldering capacitors. Whoop. Get in there. Just touch that side up. Oh, heck. God, I was lucky. That was a dry joint there. I'm amazed I didn't just push that clean off the board. Doo-doo. So, what am I doing? We're making a weird watch thing. I'll show you guys the picture. Let me just zoom out slightly. Whoop. We're building this thing. It's a really basic watch. This is a really cheap Chinese soldering kit. And yeah, we're making our own watch. So, let me bring the focus out. Oh. Focus. There we go. So there's our watch face. And we're currently soldering all these tiny little components onto the board. And when we're done, it'll be a watch. So that's what we're up to at the moment. So I'm basically talking about how you do really small scale soldering. It's a bit slow and ponderous, but if you like this kind of work, if you like something that is oddly pleasing, you're in the right place. Let's just get the focus right. There we go. I've just pulled the camera out slightly just because I was really making my life hard. Smart in quotes there. There's nothing particularly smart about this watch, but it's got a microcontroller. That means it's smart. Even if the microcontroller cost about 3 cents. Might be a bit more than that actually, because it's actually a brand name micro. Right, resistor. In. And we'll get the other side of that. There we go. And resistor. Whoop. Oh, heck. That guy's trying to jump up. Whoops. Come on. There we go. I was just trying to brush off some excess solder there, and I've just made that guy crooked. I'm going to straighten that because I can. There we go. And bloop. There we go. How long will it take? Let me see. I think we've been going for about an hour now. I think it's probably going to take me another hour or so, I would say, being realistic. I'm not sure, really. We've done a lot of the hard stuff, and now we're kind of smashing through these components. So it might come together quicker than that, but it's really hard to tell. It's amazing how time runs away with you with these projects. They look simple, but it just ends up taking a very long time. Yes, nah. No use, Slink. You should try this sometime, Slink. Borrow one of my soldering irons. Make a small kit. Not like something this small. This is mega small. Yeah, get a bigger one. Something through hole is a good place to start. We'll build a little dice or something like that. Electronic dice. Those are really good places. Right, where's the LED? We need to put the LED on it now. I found it. Hang on a minute. Here's our LED in the packet. Our singular LED. So this is our charge LED that will tell us when we're charging the battery. And LEDs are diodes, so they've got to go the right way around. That's not now, Jimbo. I've just realised that the chat covers up the person who's following, so that's not very convenient. Right. So because this is an LED, and because it's a diode, a light emitting diode, has to go the right way around. So you might be able to see that it's got a green line on it. Let's go for the close-up. Ooh, there you go. Oh, wow, you can see a lot on that. Let's go for the mega close-up. Poor man's microscope, go. you can actually see the tiny, you see that tiny little chip with the two wires in the middle there? I hope you guys can see that. I can see it on my screen, but it might be lost in compression. But yeah, you can actually just about see the tiny little chip in there. Anyway, those two green markers indicate I think they indicate the negative leg. You can make it out nice. So, which one is is that the negative? Right, so, no, that's the positive. That is the positive pin. And the positive pin, according to the schematic, they actually showed me. They have. Right, so the positive pin goes here. We've got two cut corners here, which is roughly in the shape of it. So those corners are cut off, which indicate that that's the positive pin. It's vaguely an arrow indicating the direction that the current flows in. Yeah, it's a tough one. It's really small stuff we're working with here. And plus I'm sitting here with a shaky hand going in front of the camera. Right. Soldering iron coming back up. Actually, we've got enough solder on there already. I need a really light touch with this because a lot of these components I've been able to fumble with a lot. Wow, what the hell kind of soldering was that? Let's just fix that. Oh, that's about as good as that's going to get, actually. Never mind. A lot of these components I can be very brutal with and keep the iron on it for a long time. However, this LED, I will burn this guy. So we literally just want to touch it. We just want to spot weld it and just go, done, kind of thing. Can't see anything. Oh, yeah. Let me see if I can get the camera in a little bit closer. You might have to full screen to get anything useful out of this one, I'm afraid. But I'll bring in for the close-up shot just to see if that helps. There we go. Right. Let's get this guy in. So I'm going to heat that pad up. Just push the LED into it. There we go. And now I'm just going to hold my tweezers on top of it just to hold it in place so I can flow that solder. There we go. And now we'll get the other pin. There we go. And that's it. Now we'll just reflow that one more time. Whoops, we've got a big old solder blob jump out there, thinking he's going to be slick and get away. That'll do it. Now, annoyingly, we won't know if that's the right way round or not. Yeah, there's no way of knowing if that's the right way round or not until we plug it all in. Although, actually, we might know once we get the USB connector on and the LiPo battery. Might be able to do a cheeky test there. Let's get the USB connector on, because then we can actually apply power to that and see if it turns on. We won't get anything on the screen, but it might actually indicate that there's power. Right, let's pull out, and we've got to do this huge honking guy. Right, so this is the USB port they've given me. This is a micro USB port, so this is the same kind of connector that you'd use to charge your phone. And we've got to stick that on the side somehow. The connector they've given me is not really very suitably shaped. I think they're expecting me to bend these legs out. So I'm going to do a bit of judicious bending on these. I need some pliers. Let's just bend these out. Do I usually do this? Not very often. Not very often. I used to do it more often. Haven't done it in a while. This is the first electronic stream I've done in quite a while. Which way up does this go? Let me check the diagram. Right. Oh, really? They're not using those legs at all. Okay. They're literally just going to do that. So we actually want to trim those off. But let's get that soldered down first. So let's go bleh. And we'll line that up. I'll try not to cast shadows. I might move the light around actually to where my left hand isn't casting a shadow over everything. Let's try that. Hopefully that will be a slight improvement. Now the camera arm is casting a shadow, but that should be a slight improvement. I think that's on. And let's do the other leg. That's going to need a bit of help there to stay down. Let's do that. That'll do. It's a little bit wonky. I'm going to try and improve that again. There we go. That's the ticket. Now, do they want me to trim off the legs? They haven't said so. These legs here that we're not using, I'll leave those in place for now. And then they're expecting me to anchor just by soldering to the side there. So I'm not going to anchor that in place yet. I think we'll do that at the last minute. Because once I've anchored that guy ain't coming back off again. So we won't anchor this yet. And by anchor, I mean put big old solder blobs on the side that will hold it in place. Because where we're going to be plugging cables into that needs to be a really strong connection. Otherwise, it'll just break off. Right, let's... have we populated the underside of the board? We have. That's everything on this side. So now we've got to carry on populating the top side of the board. So I think we're going to go and do a blast of resistors all the way across the bottom here now. So let's go resistor merry. So we've got... Just move some of my packaging out the way. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 resistors to do. So let me grab my package. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to leave 2 left. And blip. I'll resist your futile. Or something. I don't know. Shut up. Okay. Right. Let's tin up some pads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's go for the super close-up. I'll adjust the camera again. And I'm going to move the light because I'm casting massive shadows with it at the moment, which kind of defies the point. I might do better like that, actually. And focus. There we go. Well, I wouldn't recommend buying this one. I definitely wouldn't recommend this to start with. If you're new to soldering, this is not the place to start. However, what I would suggest is have a look on eBay, Amazon, or AliExpress, and just type in soldering kit, and you can buy lots of little starter kits for like around the $10 mark kind of thing. And for a soldering iron, for kits, start with simple kits. Look for stuff with through-hole components. So, for example, let me adjust the camera again. This widget here, this is a component tester. You see all these components here, how they all stick up off the board and they've all got legs coming out the side. That's called through-hole. And through-hole stuff like this is really easy to do when you're learning. This is all really easy stuff to solder. That's where I would start. And then basically any soldering iron will do that. Whereas what we're doing here, we're working on very small SMD, surface mount device stuff, which is very small, very fiddly, and requires a much better soldering iron. The iron that I'm using here is called a TS100, and it's It's a very small adjustable microelectronic soldering iron with a very sharp pointing tip on it. That's my little fingernail, and that's the soldering iron edge. So as you can see, it's literally a knife edge. That's how I'm doing this tiny work here. So yeah, if you want to do the really small stuff like this, you will need a more advanced soldering iron, like this one. However, a soldering iron like this costs about £100 for all the accessories. The iron itself is about $60, and you're going to want to get, well, you're going to want to get a different tip for it. That's another $10. Then you need a power supply for it, the power cable. That'll be, you know, $20 or so. So yeah, for less than $100, you could get a TS100 setup. Whoop. And for those of you playing along at home, this tip is the TSKU tip. You're going for a bit. Yeah, no problem, my dude. Thanks for stopping by. I might see you on. Whoop. But yeah, if you like what you see, as I say, soldering kits like this, really cheap to get started with. And if you buy a through-hole kit, and any cheap soldering iron will do, and you can have a go. And it's oddly therapeutic. And once you've done a couple, if you're feeling, if you're feeling brave, you can go for something more advanced. You can do something with a little bit of SMD work. Some of the kits that have surface mount on them, the surface mount stuff comes pre-soldered just to help you out. But when you look at the pictures, they'll show you all of this. They'll show you what you get, what it looks like when it's completed, what it looks like when you open the kit. What's wrong? We've got a blob of solder on the other side here. Need to just double side this. Oh heck, I've gone wrong. This guy's gone super wonky. Can I save that? Or am I going to need to get the hot air again? Nope, I'm going to hot air that. I'll come back to that one in just a mo, and I'm just going to use the hot air just to fix that. There is a technique which I was attempting to do just there, where you bounce, where you go back and forth between the pads rapidly. And if you do it enough, you can get both the pads molten at the same time. And that is how you can do 2-point soldering with an iron. However, it's a bit tricky. There's a knack to it. But it's easier for me to correct that wonky boy there with my hot air gun. So I'll get the hot air out in a second, fix that. Oh heck. Blob time. Got too much. I've got too much solder on the iron. There we go. Let's just back off a bit there. Whew. Interesting for you and me. Let's see. Let's have a quick look-see. Lipo to USB. Quick charger. Oh, that's cool. So you plug a lipo battery in and it just gives you a 5-volt output from it. That's a very cool widget to have. I like that a lot, because I've got so many lipo batteries kicking around in my shop. And it's quick charge 3. Ooh. Oh yeah, it is, isn't it? That's very cool. Yeah, could you Discord that to me, Caradog? There's a severe danger that I'm going to buy one of those later, because that's cool. I like it. Is that XT60 it's got on it? Looks like it. I like the look of that. Yeah. Cool. Right, let's put on the last of these resistors and then I'll hot air to... Actually, I'm going to hot air and fix that one now. Is the hot air on? It is. Right, hang on a sec. I've got to go onto the heatproof mat. If I use the hot air just on this mouse mat that I'm on, I'll melt it. It'll be a bad time. Okay. Hot air. I've got to be really careful around the LCD here, so I'm aiming high. Come on. That'll do. Back away. Something was smoking then. Ooh. Ow. I don't know what I expected then. That was very hot. We did it. Whoop. Specs say it's XT60. Nice. Yeah, I'm putting XT60 on all of my lipos these days, so yeah, that works fine with me. What was the input on it? I forgot to look. As in what voltage? Right, let's just touch those up with the iron. Oh, that thing is nuclear hot now. 2 cell to... Wow, 2 to 6 cells. That's a really wide range. That's really nice. It's very cool. Right, let's get the rest of these resistors in. You could easily make some stonking huge battery banks with that. There we go. Round to these side boys. No, you. 100 amp hours. Dude, that thing will be a brick. Oh no! Oh, I just flicked a resistor. That's going to be like carrying around the old Nokia mobile phone or the Ericsson or whatever it was. Oh, I found it. It's right on the edge of the desk. Cool, that's twice I've gotten lucky tonight. I probably have 1 or 2 spare resistors. But let's not tempt fate. There we go. Let's flip this guy over. Steer him into the solder. Don't tombstone. There we go. Once you get the device into the solder will be elastic and it'll hold it in place. So you want to get it going and then just correct. There we go. Literally just the slightest touch and the solder will just go straight on there. Waiting to get a Chromebook that will have USB. Oh yeah. That's interesting. Yep, that's a very interesting idea. Okay. How are we doing? We're at the 2-hour marker. So we're going to come up here. We got capacitor, resistor, 2 diodes, resistor. So 2 more resistors. Let's get those caps in place. Yeah, let's do the capacitors. So I'm going to turn around again. Turn around, bright eyes. 20 hours. When the zombie uprising comes, you'll be the one who's laughing. I think these are the last capacitors. We've got 1 more left in the packet, which is probably a spare. Get you in place. Heck. That'll do. Quick roll your head. Right, let's just hold that down and flow it. There we go. And am I running I'm running a solder blob. There we go. I'm just going to inspect that. Yeah, I know that feel. That's why I ended up buying my this is just the focus, just so I can inspect that. That's why I ended up buying my Latitude. I really wanted an XPS, but I'm like, I don't need an XPS. I'm just going to inspect those caps. Oh yeah, those are hunky-dory. Got a lot of flux in that joint. That's all right. All right. I hope you guys have a good view here. It looks good on the screen. I'm hoping it's coming out. Because we're working really, really close here. Again, just little fingernail for scale here. And also for other bananas for scale. That's a ballpoint pen. So yeah, we're working really, really small. This is a bit bonkers. Oh yeah, you still got your Surface Book, yeah. Oh yeah, 2 cores. That's going to be a bit painful. That's why I got rid of my MacBook, because my MacBook was 2 cores as well. And yeah, it's no bueno. Yup. 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 All right. And all right, we'll do these guys, then we'll do the 2 buttons. Or the switches, to be precise. Okay, so we've got 2 resistors to do. Where have my resistors gone? There they are. Oof, we had exactly the right number of resistors. Good thing I didn't lose any. Shiny, shiny, yeah. Have you tried to sell your Surface Book? Alright, I've got to turn this around. This is going to be awkward to work on. How am I going to do this? I think I'm going to do it that way around. No, Hugh. I do not need a Surface Book. Oh, it's stuck to the soldering iron. Oh, please don't cook. There we go. Now I'm going to turn around again. Yeah, oh man, really old Alienwares and really old XPSs are such a tragedy because they're so big and badass, but they've just got no horsepower anymore. And it's just sort of, yeah, it seems such a shame to get rid of them. I need to turn this around. Seems such a shame to get rid of them, but you know, if they're not doing what you need them to do anymore, they're just a nuisance, and you could buy a modern laptop that's half the size, half the weight, with triple the battery, that'll do all the same work. Hello, Andy. We're making progress. We've nearly finished populating the main board now. So yeah, we're making good progress. Whoop. Whoop. Get on there. There we go. No. Don't do it, Caradog. Don't do it. Not PayPal credit. Remember the mantra. PayPal is not a bank. PayPal is not a bank. I was just going to say, I'm waiting for Slink to show up and go, did someone say PayPal? Let me tell you a story. Whoops. I just brushed my soldering iron against something that smoked. Right, it's time for the MELF packages. The rollaway diodes. And position. i9 and 32 gigs of RAM. I bet you can. I tell you what, Hugh, if you want something flash, have a look at the new Linus Tech Tips video. It might be on Short Circuit about the new Asus laptop with the Ryzen 4900 in it. It's AMD's brand new flagship mobile processor, and it destroys everything. It's a wrecking machine. It's fantastic. Right, which way around do these diodes go? I'm going to check the diagram for the diodes. They go black stripe toward the outside of the board. So that's going to go on like that. And I've got to immediately rolls off the board. See what I mean by roll away? I'm going to turn this around so my hand is on the right side. I've done this all wrong. I think we can make this work. How much are those Asus laptops? I don't know. Oh, I think they're about $1,400. It's $1,400, but for what you're getting, that's with an RTX 2060 as well. So it's a pretty decent laptop. It's expensive, but I think it's fairly priced. That's how much a gaming laptop costs, Oh. Where the hell is the black stripe on that? Oh yeah, it's at that end, I think. Ooh, I think those are on. Ooh. Fair enough. You also return with Jaffa cakes. Not bad. I could do with a snack in here. I'm going to get a drink in a minute. I'm going to grab my multimeter and just check that this diode is the right way around. You'll notice that this diode has a very clear black stripe there. However, this one, I think that's a black stripe, but I'm not sure. So I'm just going to check that, because if we get that the wrong way round, we might have a bad day. So we're going to put that to the test. Whoop. So we are going to a continuity test. Right, so I've got my multimeter, and I've put this in continuity mode, so it's going to beep when the probes touch, like that. So I think we need to put black probe on that side. Nope, other way around. Nope, okay, I've got to go into diode mode then, so it's not going to beep. Open line. Oh, come on. I should know how to test diodes. There we go. And 0.5 drops. So let me give you a top-down view so we can show you how we're testing here. Focus. That'll do. I think you guys can just about see what's going on there. Right, so when I put this across in diode mode, it shows me that there is a 0.59 volt drop. So we're passing power through the diode, and we're losing just over half a volt going through the diode, which is completely normal. Now, if I do the same orientation on this one, we should get the same result. And we do, 0.6, within the margin of error. So that's how I know that both of those are the correct way round. And while we're here, I can also check this LED as well. If I turn the light away for a sec, we should be able to get this thing to light up in diode mode. So one way around, it should illuminate. And the other way around, it will not illuminate. There we go. It's a green diode. Now we know. No, Hugh, not the Helios. Don't you do... No. You don't need the Acer Helios. That's a stupid laptop. It's a stupid laptop. It's like the worst of Alienware dialed up to 100. Right, let's go back into the super close-up mode. And focus. What would you like it to come in? 19-inch? Remember when Acer were trying to make 21-inch laptops a thing? Mobile desktops. Okay. Right. So that side of the board is populated. That side of the board is populated. There's our positive and negative switches. So let's put on our switches, and then I think we're ready to try and put some power on this thing and see if it does anything. Oh, we've got to put our battery clip on as well. We're getting close to power up though. It's not what a laptop is for. Okay, right, how the heck? Right, which way up do they expect me to put the switches? Switches go the correct way up, okay. So I'm going to tin up that pad there. Oh, my soldering iron's gone to sleep. Here we go. Oh man. Let's try and turn this around to an angle where I can actually do it all. Ugh, I hate surface mount switches like this. Heck. That's not going to work. I need to bend those legs out a bit. And I need to do some modifications to this thing. They're bending the rules a little bit. They want me to just bend things around to make them fit in. They've done this just so they don't have to use custom components, which is fair enough, but it just means you have to use a little bit of, I don't want to say ingenuity, but a little bit of nous and look at it and just be like, oh, there it goes. You've got to use a little bit of nous just to look at something and see what are they expecting me to do here. Oh, come on. Are you sure? Well, I guess it'll work. Oh, hold on. No, I have done that the wrong way up. Yeah, okay. That needs to be upside down. That makes a lot more sense. Ugh, right, I'm trying to give you guys a view, but because I'm working literally under the camera here, it's tricky. Yeah, that's better. Oh my word. Okay. Whew. Okay, right, let's do this. And we've got to get that guy down there. I might have to go quiet for a sec while I go into try-hard mode. Get on. And I'm just going to hold this up just so I can bend that into alignment. Oof. Are they sure? Oh, heck. Ooh, did I just screw the pooch? Nope, we're okay. I snapped the solder joint off, but we were okay. This is really tricky to balance. I'm trying to figure out exactly how they expect me to get that in there. I might actually just bend these legs out even further. Out they come. Like with the USB port, I can always bend them back in. Whoop. All right. Right. And let me try and bring this up just so I can see what we're doing. Wendy's are streaming it. They're just sassing everyone. There we go. I think that's too low. No, I think that's about right. It's just not anchored. Right, I'm not going to be able to give you guys a good view here. These switches are horrendous to solder into place. I'm just going to kind of muddle this through. There we go. Right. Now I've got to try and angle those legs so they can anchor onto something. Heck. Solder blob, save me. Heck, that'll do. Whoop. Yeah, they've got a good social media game. I'll give them that. I wonder if their employee care is good. All right, I've just bent those legs slightly, so now we're gonna put a big old solder blob on there. I think I got it. No, I didn't. That needs more solder. Just want to blob that. There we go. Whew. I'm not going to do both sides of that yet, just because those switches, yeah, I don't like the way these things fit at all. So I'm not going to commit to those until I'm certain that I've got that right. Firstly, solder the 2 pins, then solder the supporting point. I'm going to try something different for the other one. I'm going to bend the support points right in. So I'm just going to modify this in midair. Super fiddly. Oh, that didn't go the way I wanted it to. But it'll probably do. Okay, that guy's going to go in there. Whew. And solder. Oh, look at all that movement. There we go. That guy just went straight in. And I'm just going to bend one of those legs back out again so I can solder it. These switches are really sketchy. But I don't need this thing to last, so who cares? Okay, right. Blob. Big ol' solder blob. That'll do. That should be right. Whew. Switches. Right, let's do the battery clip. And then I think we can try and power this thing up. And this guy's got a bend because it's designed for surface mount as well. And they're putting this thing through hole. No, they're not. Those holes are not big enough for through hole. I will trim it. Oh, nope. That's not going to trim. I will bend it. I will grab a different one and I will surface mount it. Yeah, I watched that. I rewatched that video as well. Oh my god! Oh lord! How on earth do they expect me to put this thing on? We're going back to the through-hole plan. Let me try and trim that down again because there we go. That's heckin' dreadful. Right, have I gotten that enough? Yep, that will do it. The holes they've made in the board are not quite wide enough for the pins on these battery things, so I'm just trimming them slightly. Okay. Right. And that just about clears that transistor. I'm just going to bend that guy in. There we go. Right, let's flip that over and solder. Hoodoo. Ugh. Ever get that feeling there's a ant crawling on your neck? Gross. Done. All right, that's that guy on. Phew. Right. Let's assess. We have built it. Everything is populated. God, that was a lot. That was a long... This kit did not look this huge or this hard. This is one of the hardest kits I've done, I think. That was hard work. Really good challenge for me, though. I enjoyed this one a lot. Let's see if it works. So, theoretically, it should be able to be powered from USB at the moment. Conveniently, I forgot to bring a power bank in. Have I got a crappy power bank anywhere? No, I don't. I need to grab... No, I'm just going to have to grab a USB charger and run it off that. Heck, I like to run things from power banks because it doesn't matter if you blow a power bank up. Right. Oh, let's plug that in down there. Right. I'll turn the light off because it's probably not going to be very bright. Here we go, everyone. Will it smoke? And... Ah! Look at that! It works! So, that flickering you're seeing is the display being multiplexed. Let's push a button just so it wakes up again. I can't see that flickering in real life. So yeah, that screen is to the naked eye, that screen is 100% stable. However, my 60 frames a second camera can very clearly see the flicker. Let me just wake it up again. It only comes on for 10 seconds at a time. I think. Has it died? Oh. And then it died. Okay, hold on. Let's unplug that a sec. Oof. I'm going to anchor the USB power. Let's get that soldered on properly. I hope that didn't work for 10 seconds and then explode. I'm going to be really sad if that was it. However, it worked. It worked for a small amount of time. Let's make sure that is 100% straight, and I need to anchor it. And that side. Oh, that's too much solder. If that flows into the port, I'm really screwed. Whoop. Come to the side. Blob, please. No. It's not going to plan. Oh, that first corner was so easy. And now the solder is just not flowing where I need it to. Let's spin it round. Come on. It's not bridging. The one time. You can leave it to solder to never bridge when you need it to, and always bridge when you don't want it to. Solder eraser, go! Heck. I'm going to quit while I'm ahead. Otherwise I'll just melt the port. Ow! It's hot. Okay, let's try that. Okay, firstly, I have a battery that doesn't fit properly. That's going to require some modifications. Let's get that battery snapped down. We need to do a quick bit of making good here, and then we can try it again. Just pressing down this battery snap just so that holds down better. And we'll bend in those flaps. Whoop. There we go. That's going to enable it to remember the time if it doesn't short out. Don't like that at all. Right, okay, let's try and power it up again. Did the switches break off? They did not. Right, second attempt. Oh. Has anything exploded? It was working. Ugh. Has the thing cut out? It works for a short amount of time. I'm going to leave that battery out just because I'm concerned about that battery gets awfully close to some of the other components. I don't think anything could have gone bang. So look, I'm going to stick the display down so it's not flapping about in the breeze. I'm going to commit to that. Okay. And so now that's a bit more controllable. Everything is in place. The switches are a bit sketchy. I'm just going to reinforce the switches and then we'll try it again. I'm happy it worked once, but I'm going to be really sad if that was it, if that was our lot. Oh, soldering iron's gone to sleep. Charging up. I've got this on a smaller power supply at the moment, so it takes a moment to heat up. There we go. I've just touched up the switches there, so those are actually stable now. Okay. Let's try it again. I hope something didn't just burn out in an instant then. There we go. It's back. Phew. Okay. Very flickery display. Right, let me just step the frame rate down just so you guys can see what it looks like properly. Let's go in for a close-up. Yeah. The time has not been set. Right, Brio. Right, let's see. FPS 30. Okay. And bam. Oh, has it died again? It's died again. I don't think it's very happy because it doesn't have a proper power source. Yeah, it's gone to sleep again. The power LED is very faintly on. I think we need to give this thing proper power. We'll wait a second. We'll try it one more time. Just so you guys can see that LCD properly. And then we'll get the battery connected to it. Oh, everything looks horrible because we're at 30 frames a second now. It's all janky and horrid. It's gross. All right. Nope. It's got a mind of its own, this thing. Let's try giving it lipo power. Let's get the frame rate back up again. Oh. There we go. We're back up to 60 again. That's better. And I'm going to plug in the lipo cell. Ugh. Every now and then I see a tiny speck of dust go across my glasses and I think it's smoke. Right, I have no idea if this cell is charged or not. I'm going to assume that it is. If not, it might stabilize once it's actually got a battery on it. Okay, negative on the outside. Let's do the positive first. Oh, I'm doing that completely off camera. This thing's going to get really pissy because the power's going to be really flickery. I hope that I don't short it out. There we go. Right. How's that? Is that enough to power it? Nope. Let's plug it in and see what it does. This is very hit and miss, this thing. All right, it's alive. Well, we have a charge light. I've no idea what it's doing. If it's doing anything at all. It's not responding to the buttons. Have we got a poor connection at the buttons? No, those are soldered in. Let's replace the coin cell. Stick that in. So it's got everything it needs. We've got a power light on it now. It's going to be a watch. What's up, Dying Land Shark? However, it's not working very well. Let's peel that off. Get that out of the way. What are we supposed to do? Yada yada yada. Press set and up buttons at the same time. Oh, okay. Look at that. Reading the instruction manual yields new information. 1, 2, 3, 4, 5. Nope, that did not wake it up. Long press set button to enter setting mode. I think it's supposed to wake up just when I press a button. But we're not seeing that display again. If we unplug it, the light goes out. But the display is not waking up again. Something's not right there. Maybe it's a bad connection on the microcontroller. Remember 2 hours ago we had trouble with that guy. I'm going to desolder the battery again, the cell, and we're going to pull that out. Whoops. Don't mind me. I'm just going to poke that back out because that's not helping us right now. Let's get that out of the way. Wake up soldering iron. So we're going to take the lipo cell back out. And then we're going to go over the microcontroller soldering joints. That's our most likely culprit right now. So let's pull this cell out. I've got to do this without shorting it out, hopefully. I'm not going to do this on camera because if I get this wrong, I'll short the lipo cell, and that's a bad time. There we go. Let's do that. Delicate work ahead. Come on. I need to hold this at such an angle that I can pull on the wire. That's one. Ugh. Don't touch anything. That's two. Now we're just going to bend those wires just so they can't touch. Because if you short a lipo cell, you will have a bad day. There we go. Phew. All right, the device is powered down. So it kind of works. So what I'm going to do, let's do a close inspection of the micro and see if we've got any suspect joints there. I'm going to put the... I'm going to keep going. Yeah, I'm going to keep going. I was tempted to go and get some tea, but I'm going to keep going. Close-up inspection. Right, those guys are all good. Those guys are all good. Oh, we did this. We went over these. Ah, far left. That looks suspicious. And that guy's good. Pin 1, I don't like it. What's pin 1 do? That looks like a really important pin, according to the diagram. Let's retouch that. I'm grasping at straws. I don't think this is going to be it, but we're going to try. It's so close to working. I'm going to be incredibly sad if this doesn't work. There we go. That guy's definitely soldered now. Right, while I'm here, let's inspect everything else as well. 200 more in pounds than dollars. Oof. That guy's fine. That guy's fine. Just going to go around the board and just check all those connections. Yep, that's all good. Some of this soldering is rough as guts, but it's all there. Yeah, that's fine. Yep, that looks good. Let's try it again. It works for a short amount of time and then it dies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Let's power it up again. Huh. Nothing happening there now. I'm going to power cycle the adapter. It flashed. I'm going to check for short circuits. Where's my thing? There it is. I'm having doubts, you guys. I'm having mega doubts. It worked for a short amount of time, but I think something about this thing ain't right. Let's check the input. It's not shorted. Because that's cataract with the follow. Thank you very much, my dude. Yep, no short circuits. Okay, what else can we do to diagnose this? We could put power on it and see if we've got basic functionality. So power to the micro and a clock signal maybe. Although I don't know. Pin 5. 7 is a clock. Maybe. Let me grab my oscilloscope and we'll see if there's any life in there at all. We'll see if it's thinking. Does the black spot on the 1 and 2 red tubes matter? It does. However, they are the correct way. Oh, let me just double check they're the correct way around. Oh, good grief. They're not the right way around. You're absolutely right. They're both the same way around, but they're not the right way around. I may have blown something up. If I'm lucky, I haven't destroyed it. So yeah, I just checked the picture again. In the picture, you can clearly see that the black line is on the left toward the switch. However, my one, I've got the black line on the right. So yep, you're bang on, Helkith. Well spotted. Right. Oh, I can't hot air those. Can I? I'm going to try it. I've got to risk the hot air on those. I sure as heck won't be able to desolder them with the iron. Right, and turn around. Turn around. Oh, roll away package. You can tell I'm serious because I'm just hot airing it now. Mates, what's up, Davey? Welcome to It Doesn't Workville. Oh, we've just melted the adhesive for the LCD, the OLED even. I may have just melted the OLED as well, because that was glued to the back. I did not think then. Let's hope I haven't just screwed the pooch. Right, here goes nothing. Whew. It worked. It came on for a moment. Oh, come on. It's so close. Oh, it's so close. It worked for a split second. Ah! Oh, this is going to be a watch. Well, it's not going to be a watch. I'm desperately trying to save it and turn it into a watch. Come on. It's trying. I'm going to keep it awake. As soon as it goes to sleep, it doesn't come back on. It's something to do with those. It's something to do with the switches. Let me check those diodes again. Something to do with those. It has to be, because it's the switches that are not doing the job. Right, diode 1 and diode 2. Black bands go on the left. Resistor below. J3Y at the top. J3Y at the bottom. Okay. Right, let's try giving it its standby again. Grasping at straws here, but we'll give it a whirl. Doo-doo. Ugh. Okay, right. Work for me, dude. Work for me, I believe. Oh, it went off after a super short time then. It seems to work longer if it's been left a while. Should we try giving it battery power again? Positive on the left. I'm going to try giving it battery. Whoop. Let's try and get this soldered on. I'm trying to do just a really dirty, easy to remove solder job here. Come on, a bit more solder. Oh, come on. Oh, don't mess about with me. I'm trying my hardest right now. There we go. And let's get a solder blob on that side. Okay. Straighten that one. Okay. The battery is reconnected. Whew. Yeah, I may have already broken it by doing that. We had two diodes the wrong way. Hang on a sec. Let's look at the schematic. What were those diodes doing again? They were part of the standby circuit. So that is switch 1. Right, so this diode was the wrong way round. Oh, actually, what we did was we were preventing switch 1 from working. Which one is switch 1? Switch 1. Switch 1 is the top switch. Yeah, switch 1 would not have been working. That's the up. That's set. So the set button would not have been working. However, because these diodes oppose each other in direction, we actually wouldn't have damaged anything. There just would have been no power going anywhere. Ah, we would have pulled S1 to ground. Oh, that's fine. Yeah, no, I think we're okay. I don't think we damaged anything. And it works. It's running on battery. No, it's not. Hacking! Why won't you live? Why do you refuse to live? Have charge. The battery percentage has a frickin' mind of its own. It has no idea what way is up. That flickering, again, that's just the multiplexing. Let me just see if I can show you that without. Let's switch back to 30 frames just so you can see what it's supposed to look like. That didn't fix it at all. Hang on a sec. Let me switch down to a really garbage frame rate. How about 10? Look at that frame rate. It's beautiful. However, surely this won't see the flicker. This is not helping. There you go. It's stable. It looks like a PS4. Am I right, lads, or am I right, lads? Okay, let's have 60 frames a second again. Whoop. There we go. Yeah, I don't know what the percentage is doing. It seems to have stabilized now. Let's... Oh, no, it hasn't. Right, hang on a sec. 1, 2, 3, 4, 5. Yeah, that was a hard reset. Okay, so now if we hold down set, 1, 2, 3, 4, 5. There we go. We're setting the date now. It's working. I think we've got it. 20. I think we've got it, y'all. Right, so this is the month. Where are we now? The 3rd? January, February, March. Yes. 31st. Oh, we've got to go all the way to 31. Oh, this was exciting. I genuinely thought we were screwed. I really thought we'd had it. Right, we're on 24-hour time, I assume, here, so it's 21:58. Oh, crap, I've gone round. Does it have rollover? It does not. I have to press the button another 21 times. $59. Right, if I sit on this screen and just wait for the real time to roll over to 59. Right, date display mode. That's correct. 24 hours. Sure. Display week mode. Tuesday. Oh, I see. That's language. So we've got English or Chinese. Because that is the that's the kanji for 2, as in the second day of the week. Hello. There we go. Right, I can't do anything about that flicker. As I say, to the naked eye, that is not flickering. It is completely stable. Right, if we press that, it wakes up. Yep. So, I'm gonna... Where's my... let me grab... let me grab my multimeter, and I'm just going to probe some voltages and just see what the hell is going on with the power supply to this thing. Right, so firstly, what power have we got at the cell? This is probably going to be high because we're charging. Let me just the focus. Oh, that's a 4.1. Yeah, this cell is charged. Let's take that off a sec. Is this lipo battery just bollocks? I mean the control chip, that is. Okay, so you can see our voltage is dropping now we've come off of charge. So no, it was not charged. We're falling steadily. I think that's going to stabilize around like 3.9 or so. So we've got a lot. It does have a case, yes. I think, yeah, I think that is working, and I think I'm going to build the case. Yep. And it has come out of standby and remembered the time. Okay. Whew. Let's make the case. Gah. I thought we'd had it then. I really thought we'd had it. Is that going to fit in the case? I don't know if it will. I don't know if it'll fit in the case. This lipo cell might be a little bit too big. But we ain't using the horrible 4-button cell board that it came with. That's just crazy talk. God, that was a wild ride. I'm not sure what we did to fix it. Maybe just... oh, it's Migos Moo with an auto host. Thank you very much. I'm not sure what we did to save it. Maybe it was just reflowing those connections around the micro that did it. Oh, no, of course. It was the heckin' buttons, wasn't it? We're making a smartwatch. Well, I said a smartwatch. We're just making a watch. So it's not in a case yet, but if I press the button, it wakes up and it displays the time. I know it looks flickery. It looks normal to the naked eye. That's just the camera playing tricks on you. So yeah, there's that. Oh no. It's one of these horrible kits where you've got to peel off all the sodding stuff, and I forgot to do it. Right, hold on a sec. We're now going to have a momentary moment while I have to strip all of this nonsense off. I always forget to do this in advance. Let's see if I can make quick work of this. Hello, Zolly. How's it going? You missed all the fun and excitement. It wasn't working, and it turned out heckin' Helkith with the laser vision. Were you grasping at straws there, Helkith, or did you actually spot it? You haven't been playing long as you went at home by any chance, were you? Foxcube, thank you for the follow. We don't do this every day, by the way. However, I do want to get into the habit of doing more of these. Because, yeah, it's not something you see every day. These are just kits that you buy off of eBay or Amazon. Anyone can try it. This was a very difficult one, though. This was definitely one of the hardest ones. Right, I'm not going to do all of these side pieces. We'll just do the top and bottom now. Batteries for my for your modem. The hell? What's going on with that? Did I win? I did. It lives. Bam. And yeah, again, it flickers, but that's just, yeah, you can't see it with the naked eye. I did try and stabilize it for the camera, but yeah, small devices like this, the reason why you get that flicker is it uses a process called multiplexing, where it turns the screen on and off very rapidly in order to change the contents of it, because it can't drive every part of the screen at the same time. So it's actually drawing it line by line. And what you're seeing in that flicker, what you're actually seeing is the lines going really, really quickly. And on really good devices, the multiplexing rate will be so high that cameras won't see it. However, this is being run by some poxy cheap Chinese micro that's probably only running at, I don't know, a couple of megahertz if you're lucky. So yeah, there's that. Nearly done enough. Got one more and then we're going to start assembling. I hope the lipo cell will fit in the case. That's going to be a bit of a bummer if it doesn't. Oh, the backup battery ran out and forced it to turn off. That's a bummer. Okay, right. So how the heck does this case work? We have instructions for this. Whoop. So 1, 2, 3, 4, 5, 6. I'm assuming one goes at the back. So 1, 2, 3, 4, then 5 is these bits. Heck. And then 6 goes on top. Right, okay. And the bolts go through, where are the screw bolts? That's these boys. Okay. So those are going to go through there. Do those snug fit? They do not. That's okay. And are we putting screws in from both sides? I think we are. I'm going to be really sad if the battery doesn't fit. I might modify it if I have to. I can be reasonably risky with this cell. The lipo cell I'm using, this does have a protection circuit on it. That little circuit board on the end of the battery, that's a protection board. And it's actually got a tiny little controller in it that checks if there is too much power going through the cell. And if the voltage is too high or the current is too high or if there's just a problem with it, it'll cut the power. It won't stop terrible things from happening, but it will stop it from melting down your house. Right, let's try and put that in like that, I think. It might just work. Right, so then 2. Oh, am I going to peel these properly? I really should. No, I'll take it apart off camera and finish it properly. Modifying. Oh yeah, I'm not going to modify the cell per se, but I might just get the Dremel and just grind out part of the case if I have to. That's what I meant. Right, then that part goes on. Now I need to fit the strap. Here's the genuine leather strap that came with it. Look at that, it's genuine leather. Allegedly. Right. How does the strap of a watch work? The long bit goes on the bottom. So those are going to go through. Oh, I hope that bit was supposed to come out. Can I put that back in? No, I don't like that. I think that was supposed to come out. Oh no, I've done terrible things. Heck. I've put a bit of plastic where there was not supposed to be a bit of plastic. Let me trim that off. The brand is terrible. Oh no. I'm pretty certain. Well, yeah. Yeah, that could be a thing. Right. I think we've nearly saved this. It's going to go in there. I think. It's a really poor fit. There we go. And the other one. Plastic tube doesn't want to come out of that one. I'll try pressing it through. Okay, this one's pressing through. This is okay. Might just have to adjust that though. Trimming off camera just because it's easier. There we go. Oh, I don't like that. Come on a bit further. There we go. It's all coming together, boys. Right, what's next? Next is 4. That's that bit. Now the device goes in. It fits. Oh my gosh, I think it's going to work. What's up, Master Pro? I was supposed to take the brown to... Okay, who is... Oh, I've broken that bit. Whoops. Who is willing to watch me peel more brown tape? Nope. Okay. There's your answer. That goes on there. We are leaving. That does not fit there. Oh yeah, that needs modifying. Hold up. I've got to trim the USB port. Oh, I'm ruining my cutters doing this. That's okay. That's why I have spares. Okay, 4, then 5. And that lipo cell, that needs to go around in such a way that it clears the backup battery. I think that just goes like that, actually. I think that's supposed to sit Like there. There's loads of space back there. I think that's how this works. Oh yeah, those the power wires can't be there. The power wires need to be on the other side. We've got to remove those. All right, soldering iron on. Whew. Okay. Right, let's redo the lipo cell one last time. Again, hopefully without shorting it out as a special treat. Has this thing got a motion sensor in? Because it just seems to turn on at random now and then. It wouldn't surprise me. Whoop. There we go. And onto the other side. And negative. There we go. Pretty janky connections, but it's passing so little power. A 400 watt LiPo charger. Yeah, because I'm pretty certain you need to charge your airsoft batteries at 7 amps. Or 8 amps. I don't know if that's going to do the job, but I'm going to try it out. Right, where's the thing gone? Here we go. Yeah, I think that'll do it. Is it still alive? It is still alive. However, this hacking thing... Well, that one. Doesn't quite fit. Oh, it does. Oh, it does. It fits exactly. Just needs a little bit of encouragement. I doubted it. Oh, we can't put that on with a big old fingerprint on it. Right, let's de-fingerprint. What a wild ride this one has been. This has been a good build. I think we've got this about right. Was it meant to have that battery in there? Sort of. It came, the kit came with this board, which is supposed to have 4 button cells on it that goes in the bottom. However, I observed on the design, and the instructions also clearly state that you can power it with a lipo cell. So I said, screw the button cells. We don't do those around here. We put lipo in everything. Because lipo is awesome. You know what's not awesome is the fact that these studs don't reach. The studs are not long enough, and the strap is broken. Let's do a bit of that. The straps are not going to be operational. However, if you thought I was actually going to wear and use this thing, you are quite mistaken. Okay, that's one. And screw. Lipo was painful. Oh, Drinky. You're so witty. Okay, we're nearly there. You know, as far as these plastic cases go, this one's actually not half bad. I almost wish I'd taken the time to do all the peels now. Ah, there we go. It's a shame the straps broke straight away. I'm not sure what part of them thought that was going to work. Bummer. I mean, I might be able to mod something in there. Will it stay? No, it won't stay in place enough for demonstration purposes. Wah. Well, so what should happen? Ooh. Get my skinny wrist over here. Imagine that the strap works and I raise my watch and I do that. No! Why is it broken? Ah! Hecking. Does it need power? Right, it's still keeping to... I think that battery might be low. Ah, there you go. We've got 15% battery. Maybe. I don't have I don't have Boom installed over here, so no clips. Yeah, it works. I think the lipo cell is low. I think that this lipo cell has been sitting in a box for over a year. So yeah, I think that's died again. All right, let's keep it plugged in. Wake up, damn you. I think it's died. Yeah, I think the battery is too low. So yeah, the lipo cell we've put in the bottom there doesn't have enough charge in it. However, yes, at the cost of carrying a bare lipo cell with a small bit of perspex between it and my veins, we have a working watch. Has it got enough yet? There it goes. It's fine. Banging. The bulkiest of watches. Honestly, it's no worse than a lot of the smartwatches you see these days. It's why I don't like smartwatches. I think that I'm not a fan. But yeah, there you go. Smartwatch did it. Oh yeah. Well, this is a fitness band, and this is the only thing I'd wear. Let's compare that. Oh, that's my fitness. It's very dark. That's extraordinarily dark, actually. I don't know why my watch has decided to stay dark. Actually, where's my phone? I think it's because my phone thinks it's dark. Hang on a minute. No, I've no idea. Anyway, the thing works. Blah. That's it. It doesn't know what the battery charge is. But what I'll do is I'm going to leave that plugged in. And if you tune into my next stream, which will be on Thursday, I'll let you know whether it was actually functional or not. But yeah, that was a very exciting turn on, and it's functional. And with that, I think I'm going to call it a night, because I'm not going to get started on anything else now. I'm plumb tuckered out. We've been going for 3¼ hours, which is pretty good for an electronic stream, I think. So I want to thank everyone for tuning in tonight. That turned out to be quite the cliffhanger edge. I genuinely thought it was broken. And I was like, heck, that's another project that didn't work. But there it is. Right, let's find somewhere to go. And I'm going to catch up with you guys on Thursday. So let's see. Oh, not that one. I want mixer.com. I'm going to find someone to send you guys to. com/following. Whew. Oh, following is actually a channel. How about that? You got to go browse following. Yeah, someone scooped that up, didn't they? Right, let's see. I think I'm going to kick you guys over to... Lyndon. He's doing some Bless Unleashed. So I'll see you guys there. Thank you for tuning in, everyone. Good luck with that, Caradog. You will spend a lot of money. It looks cheap, but then you fill up your shopping basket with stuff. Thanks for tuning in. Thanks for sticking with me in a moment of grave peril. And we built a stupid watch thing. And we fixed Kimbo's mouse as well. That was the other thing we did. I will see you guys on Thursday. I will be back online with a game. I don't know what it'll be, but I'll be streaming here on Thursday at 7 p.m. UK time. Have a nice evening. Good night. Bye for now, everyone. See ya.